Hello again. As you know, I'm Eli the Computer Guy over here for everymanit.com, and today's class is network mapping. So we are going to talk about how you map a network. Basically, all network mapping means is that you plug into a network and you try to figure out what is on the network, what services are available on the network, what shares are on the network, what computers are on the network, what access points, what's routers, what servers, etc. The big problem, especially for consultants coming in to a computer network that is already up and running, is many times you have absolutely no idea what is on that network, and the people that are hiring you, they really have no idea what's on the network. So you ask them how many computers they have, they shrug their shoulders. You ask them how many switches they have, they shrug their shoulders, access points, etc. So by being able to map a network, you can figure out what is on the network. So basically you can figure out where to go from where you are. Also, another good point with learning how to do network mapping is a lot of modern networking equipment, when you plug it into the network, it uses DHCP to automatically grab an IP address. So you plug in a wireless access point, you plug in a network printer, etc., and they automatically grab an IP address. Well, if you know that IP address, you can go to your little computer, you can go to that IP address, and you can get into the nice little web interface and administer that printer or that access point or that router. The problem is if you don't know what IP address that device has, it's very difficult to get to it. So by understanding how to do network mapping, you can automatically map an entire network and then be able to find all of your wireless access points, all of your printers, all of your computers, etc. So this class is going to teach you how to map a network. We're going to talk about the basic services that are required that you use to map a network: ICMP, port scanning, SMB, server messaging blocks, SNMP, and such. Going to tell you about the basic process of doing it, just so you have an overall idea why you would map a network. Now, this can be used for good and bad purposes. This can be used as you as a consultant going in just to figure out what is going on with the network, to figure out what the servers are, what the access points are, etc. This can be used for security. So you can go in, you can do network mapping to find out what shares are open that shouldn't be open, what ports are open that shouldn't be open, etc. Or you can use this for hacking, where you go in and you find out that people left a whole bunch of folder shares wide open on the network, and you can just hack away as you please. So depending on what you're doing, you can use network mapping for your uses. So give me a second. I'm going to put a couple of things together, and then we are going to get into this class, network mapping. So when you're doing network mapping, there are four basic components to the systems and to the networks that you should understand that you are going to be using to map out the network. The first is something called ICMP. This is called Internet Control Message Protocol. This is a protocol that is part of the TCP/IP networking suite. So if you're using TCP/IP, which in this day and age, just about everybody does. I don't know why you wouldn't be using TCP/IP. Then within that TCP/IP is ICMP, Internet Control Messaging Protocol. This is the protocol that allows computers and networking devices to talk back and forth and send error messages. So on the very lowest level, this is how computers and devices can talk and can make sure that another device is there, and if it's not there, can send error messages back. Basically, what we're going to be using ICMP for is something called the echo request. So the echo request is where your computer calls out to a computer or device on the network and says, "Hey, are you there?" So your computer goes, "Hey, are you there, router?" And then the router says, "Yes, I'm here." "Are you sure you're there?" "Yes, I'm sure I'm here." "Are you really sure I'm here?" Yeah, etc. So basically, your computer calls out to whatever computer device on the network, says, "Hey, are you there?" Well, what's supposed to happen is your computer will call out to that device. That device is supposed to respond back, say, "Yes, I'm here." Well, with the echo request, three things can actually happen. Your computer tries to talk to that network or computer device, and that device comes back and gives you an echo response that is crystal clear. So everything works perfectly. Or it can give an echo response, and from the information within that echo response, you can see that there are errors. So it's not that the network cable is unplugged entirely, or that network device is powered off, but for some reason, the communication isn't going back and forth as smoothly as possible. So it's a second thing that could be happening. Or the third is that for whatever reason, that computer device is unplugged from the network, that computer device is turned off, or something has just gone haywire and the CPU has blown up. So when you do this echo request, basically you can get 3 responses. Everything is good, something's going on, that's a little weird, or no response at all. This is all used using the ICMP, the Internet Control Messaging Protocol. The next tool, or whatever, that we're going to be talking about is something called port scanning. So if you know anything about TCP/IP, if you know anything about servers, you know all networking services use ports within the TCP/IP protocol. So if you're going to a website, you use port 80. SSH, if you're using SSH to get to a Linux server, you're using port 22. If you're using POP3 email access, you're using port 110. So every single network application uses its own port. So what we're going to be doing is doing port scanning to see what computers have what ports open. So by seeing what ports are open, we can determine what that computer or server might be doing. So if the FTP port is open, that might be a file server. Or somebody accidentally turned on the FTP port, and we should turn that off. The next thing that we're going to be looking at is something called SMB Shares. Server Message Blocks Shares, generally used with Windows networks. This is where you double click on a shared folder, and you can access shared folders, shared files, and shared printers on other computers. These are SMB shares. So what we're going to be doing is looking for SMB shares. Finally, there's something called SNMP. This is called Simple Network Message Protocol. What this protocol was developed for was to send a greater quantity of information to network administrators so that they could fully understand what is going on with their systems and their servers. So basically with SNMP, you have 3 things. First, you have what is called a network management system. This network management system goes and it gathers information from all the computers and devices on your network that are using SNMP. Those computers and devices on the networks that are gathering information then have SNMP agents installed on them. So these are just basically small little pieces of programming. And then what you can do is you can create SNMP traps that state when something happens with that device or that computer, you want to send an alert back to that network management system. So basically, how SNMP works in the real world is, let's say you have a server, and you're worried you do not want this server to go over 90% CPU utilization. So what you can do is you can install an SNMP agent onto that server. Then you can create a trap that says, if the CPU goes over 90% usage for 5 minutes, I want the network management system to be alerted. So your computer is buzzing along. If it goes over 90% for 5 minutes, then it sends an alert back to that network management system. Now the nice thing with these agents and traps is you can gather a whole bunch of information. It's almost limitless the amount of information that you can gather using SNMP agents and traps. You can gather all the software that is installed on that computer. You can determine what updates have been installed on the computer. You can determine all the hardware that is on that computer. So imagine if you had 30 or 40 or 100 systems in your network, and you could sit at one console and see, what computers have only 2 gigs of RAM, what computers have 10 gigs of RAM. You can see all of the hardware information simply sitting at your network management system. So you're just sitting at one little console and you can see what is going on. You can send alerts, traps. Again, if a computer goes under, let's say, 10% hard drive space where it may cause problems, that SNMP trap can send an alert to you so that you can see, the secretary's computer went under 10% utilization. Using these things, you can get real-time information into you, and you can also go out and you can quickly inventory all the systems and devices on the network. So, if you want to make sure all your Windows Vista systems are up to Service Pack 1, you can go out and you can scan all the computers and make sure they are up to Service Pack 1. The main thing that you should remember with SNMP is that there is a simple network management protocol service on your Windows system, so that has to be running. If you turn that service off, SNMP doesn't work at all. It also requires UDP, so not TCP, UDP ports 161 and 162 to work. I'll put that all in the notes in the bottom. But those are the four concepts that you should understand for mapping a network. ICMP, Internet Control Message Protocol. This is part of the TCP/IP suite. Basically, this is just a communication protocol for different devices on the network to talk to each other and basically say, hey, are you there? There's port scanning, so every network application has to have its own port 80, port 22, port 25, port 110. There's a lot of them out there. SMB, server message blocks. These are the Windows shares, so we can go out and we can scan for those shares. And then finally, SNMP, Simple Network Management Protocol. This is what allows you to gather a lot of information about the systems and the devices on your network. Now, for mapping your network, you should know some basic DOS commands. If you've done any networking in the past, if you work with DOS, you should probably know these commands, I would hope, at this point by now. But if you are new to network mapping, we should just go over 3 commands that you should understand in order to do the basics for network mapping. The first we have to talk about is something called ipconfig. ipconfig is the basic DOS command that shows you what the IP address information for your computer currently is. So if you run the command ipconfig /all, this command is going to show you what your current IP address is, what your current subnet mask is. That's all fine and good. The big thing that it's going to tell you beyond that is it will tell you the IP address of your DHCP server, it will tell you the IP address of your default gateway, and it will also tell you the IP address of your DNS server. So if you're trying to figure out what's going on with the network, you just walk into this network, you have no idea what's going on. Well, probably the first thing that you should figure out is what the default gateway is. So of course, a default gateway is your router, your cable modem, your ADTRAN, whatever gets you from inside your building out to the internet cloud. So that's what the default gateway is. Once you understand what the default gateway is, you should also see what the DNS servers are. So if you're trying to figure out how complicated your network is, this is very important. If you have a very simple network, your DNS server, your DHCP server, and your default gateway will all be the same device, whether it is a router, whether it is a Windows server, etc. If it is a simple network, DNS, DHCP, and default gateway will all be on the exact same device. If you have a complicated network, all those will be on different devices. So if you go in and you see that your DNS server is 10.1.10.2, your DHCP server is 10.1.10.3, and your default gateway is 10.1.10.1, that's telling you, whew, you have a lot of stuff going on here. Good or bad, I mean, it might not be good that you have a lot of stuff going on there, but it tells you that you do have a lot of stuff going on. Now, with the ipconfig, so it's ipconfig /all, this will tell you the current information for your computer. Or it'll come back and it'll say 0.0.0.0, which means that you have no IP address whatsoever. Now, if you've just plugged your computer into the network, You can also use the ipconfig command. And what you should do is space / if you do release, this will release the DHCP address that your computer currently has. So if you plug into a network, what I would suggest that you should do is you run ipconfig space / release, and then you do ipconfig space / renew. And this renews your IP address. So this makes sure that you have the most current IP address information. After you do this, you do the ipconfig space / all, and again, that will show you what your IP address is, your subnet mask is, your DNS, your DHCP, and your default gateway. This is very, very important information. Now, once you make sure that you are on the network, then the next thing to do is make sure that you can talk to other computers or devices on the network. This is, we were talking about ICMP before, the communication protocol. The first thing that we use with this ICMP communication protocol is the command ping. So what ping essentially does is ping has your computer call out to another computer or device on the network and ask it if it's there. So basically your computer will say hello, and then the computer on the other side, hopefully, will say hi back. Now, if the computer on the other side doesn't say hi back, then you know that you have a problem. So what happens in the DOS world is you do ping, then you do space, and then you can put in either an IP address or a domain name. So you could put in ping space 10.1.10.1. So if you're trying to figure out if you can communicate with your default gateway, with your modem. Here, our default gateway is 10.1.10.1. So if I'm sitting in a computer, I can do ping 10.1.10.1, and this will tell me if I'm talking to my router, to my default gateway. If nothing comes back, if it basically says error cannot be found, then I know I have a major problem inside my network. What will happen is after you do this ping command, it will call out and get a response 4 times. Now, if you are in the Linux world, it will just continuously ping until you force it to stop. You do a Control-C. In the Windows world, it will do it 4 times and then automatically stop for you. When it does this 4 times, basically it'll go out, it'll ping the device, and then it will tell you the time to live. It'll tell you how quickly this communication happened. So if you have a high number, you know that there's a delay in the system. If you have a low number, you know everything is doing pretty good. Now, when you do the ping for a domain name, so you say ping, let's say server, this is an easy thing because it will ping as long as your computer can communicate with the DNS server. The ping command will then resolve the IP address of the server that you're trying to get to. So let's say you're trying to get to the Exchange server. So let's say you do ping Exchange. Well, then the ping command talks to the DNS server, and it will then figure out what this IP address is, so 10.1.10.13, and then it will ping this IP address. Again, this is a very easy thing because you can see if your Exchange server is up and running, and then it will also give you the IP address of that Exchange server, in case you need it in the future. Now with the ping command, overall, the ping command is a very simple command, but if you do need to know like all of its different options, again, you just do ping space / question mark, which you should know for DOS commands, and this will give you the little description of how the ping command works. It will tell you what arguments you can use with a ping command. The 2 arguments that I would suggest that you use with the ping command or think about using with the ping command are 1, which allows you to put in how many, like the total number of pings that will happen. So let's say you send out 4 pings, 2 pings come back good, 1 comes back a little weird, then the next one comes out good. And you want to get an idea of just how flaky that the network connection may be. Well, instead of sending out 4 pings, you may want to send out 200 pings, just so you continuously keep pinging that server and see what the results are. To do that, what you would do is you do ping space, and then you put in the IP address 10.1.10.1, and then you do space, you do hyphen, and you use the n, the lowercase n as in November argument, space, and then how many pings you want to send out. So let's say 200. So what this will do is it'll ping 10.1.10.1 n 200 times instead of 4. So this gives you an idea of what's going on. You send out 4, hey, you think it's a little weird. Well, let's send out 200, and just continuously, if you keep hammering that server, do you see any network problems? The next thing is sometimes the server is very slow to respond to your ping request, and so sometimes you want to up what is called the time to live. So the time to live on a ping request, basically the computer says, if I don't hear a response within so many milliseconds, I'm going to assume that the ping command failed. Well, depending on how flaky and nasty your network is, that time to live may be too short. So what you can do is you can do ping, again, 10.1.10.1, then you do space, hyphen, lowercase I. Then, after that, you put in how many milliseconds you want the ping command to live for, what the time to live for is. Again, you plug it up to 200 or 1,000 or whatever it is. Basically, this keeps the command open, so if it's taking a really long time for that server to communicate back to you, you make sure that at least you can hear it. Again, if you have to use the I command, what this means is that you have a problem on your network. All you're doing with increasing the time to live is trying to give yourself a better idea of what problem is going on. Now, after you get done with the ping command, so you ping out, you call out to the device. The next thing you can do is, if you're trying to isolate where a problem is in a network, or trying to understand what routers or what networking equipment are routing your traffic, you can use something called the trace route command. So the trace route command is actually TRACERT. So it's trace, but it's trace route. The command is trace route. What this does is it's kind of like the ping command, only it actually gives you an echo response from every networking device that you go through. So let's say you do trace route, and then, like as I will show you in our demonstration, you do www.everymanit.com. So I'm trying to see the route from my computer here all the way to our server, everymanit.com, sitting in the data center that's a few miles away from here. Well, when you do the trace route, instead of just getting a normal ping response, what will happen is you will actually see all of what are called the hops. Basically, all the routers that this goes through in order to get to the server that you're trying to reach. So first it'll say that it's going through the default gateway here, 10.1.10.1. And then it'll say it's going through Comcast's gateway. And then it's going through another gateway, and then another gateway, and then another gateway. And then, as you'll see, then you go and you hit the data center's networking devices. And so they'll send information back. And then finally, hopefully, you'll get to the information from Everyman IT back to you. So this is a very important tool. This will make a little more sense when we go over and demonstrate it in a minute. So the basic DOS commands for mapping out a network are, again, ipconfig. This is very important. The main reason is you can go in and very quickly, hopefully, find out what the DNS, the DHCP, and the default gateways are. Then you use the ping command. Ping is, hello, hi, I'm here, hello. That's all it is. It's basically your computer calling out to different network computers or devices. Ping works for computers. Ping works for routers. Ping works for printers. Ping works for wireless access points. And depending on what you're dealing with, ping may also work for your switches. So this can hit all of the different networking devices that are using TCP/IP. Then, if you're trying to actually trace the route that your little packets take, you can use a trace route or trace command, and that will show you every single hop that your packets take to get to the server that they're trying to get to. So with this, let's go over to the computer and I'll show you ipconfig, ping, and trace route. Okay, so here we are back at my Windows 7 computer, and we have the nice little command prompt icon here. So if you're dealing with Windows 7, if you're dealing with Windows, you're going to be using the ipconfig command. You need to open up the command prompt as the administrator. Do a run as administrator. If you're using Windows XP or earlier, well, you can just use command prompt and not worry about it. So what you're going to have to do is you're going to have to right click the command prompt, and then you're going to have to do run as administrator. And of course it's going to give you this little thing and you say yes. And now your command prompt opens up. Now with this command prompt, what we are now going to do is to make sure that we have all the latest information, all the latest networking information on the system. We are going to do ipconfig, and we are going to release and renew the IP address. So the first thing that we're going to do is ipconfig /release. And this releases the DHCP IP address that we currently have on the system. It's that easy. Now, in order to renew the IP address, we do ipconfig /renew and hit enter. This makes sure that we have, like I say, the latest information. Now we've renewed the IP address. So all we do now to see all of the IP information is we do ipconfig /all. So what we did is we did release, and this is where we released. We did renew, this is where we renew, and now we do ipconfig /all. So this will give us all of the IP information for this computer. So we hit enter, and so this is our command up here. Now it says, this tells us our host name. So it says the computer's name is graphic. There's a whole lot of information here. It tells you our network adapters. So the first network adapter is a Realtek PCIe, yada yada yada. It says the physical address. So this is the MAC address in case you need it. Now it says the IPv4 address. So this is what you're going to see if you're dealing with Windows 7 or Windows Vista, Windows XP or earlier. All of this is a little easier to understand, but with Vista and such, it gets a little more complicated, but you're looking for IPv4 address. And it says the IP address of this computer is 10.1.10.10. The subnet mask, it's a class C, 255.255.255.0. Says when you obtained the address, when the lease expires. Then here is one of the important ones. What is the default gateway? So this is the networking device that gets us out to the outside world, whether it's a router, whether it's a DSL modem, cable modem, etc. So that's 10.1.10.1. So we will have to be able to communicate to this device in order to get to the outside world. Then it says what the DHCP server is, again 10.1.10.1, and then it says what the DNS server is, 10.1.10.1. Again, as I said in the in the live action blurb, if the default gateway, the DHCP server, and the DNS server are all have the same IP address, that means you have a relatively simple network to deal with. But all of these servers can be different physical servers. The default gateway could be 10.1.10.1, the DHCP server could be 10.1.10.2, and the DNS server could be 10.1.10.3. This does happen in the real world for good or for bad. So just make sure, when you're looking at this, you'll see how complicated a system that you're dealing with. So since we've now figured out what the default gateway is, we are now going to do a ping command to take a look at it. So I'm just going to clear this out real quick. So we'll open this up again. And so now we are going to ping our default gateway, that 10.1.10.1. So in order to ping that gateway, we just do ping, P-I-N-G, space, and then 10.1.10.1. So this will go out and it will call out to that default gateway and ask if it's there. So we hit enter, and now we see it's pinging, and it pinged 4 times. So 4 times that default gateway said, hey, I'm here. the time it took and the time to live. So the time to live for this request was 64 milliseconds. The time equaled 6 milliseconds the first time, less than 1 millisecond the second time, 5 milliseconds the third time, less than 1 millisecond the fourth time. So this means that the gateway is responding very quickly, so you're not having any problems. So let's say that we wanted to ping the default gateway more than 4 times. Again, all you do is ping space 10.1.10.1 space -n, and then let's say we want to ping it 10 times. So now it's going to ping that 10 times. So we ping it 10 times, and you get the information. Again, like I say, is if you're having really weird networking problems, sometimes, I plug in that I want to ping a device 200 times just so I can get an idea of how often the reply errors out. Again, we have a good network here, Cisco equipment, professional, so everything's running well. But when you go into some of these nasty networking environments, you may have corroded cable, you may have switches that are 10 years old, you may be dealing with hubs, for Christ's sakes. So so being able to do this ping command, 100 or 200 times may give you an insight onto how the network is working. Now finally, with the ping command, we need to talk about that time to live. So again, right here, it shows that the time to live defaults to 64 milliseconds. Now, what if you're thinking that maybe the equipment is responding, but it just needs more time? So in order to give it more time, we do ping 10.1.10.1 space -I, and then we put in our time to live, a longer time to live. So let's say we do 200 milliseconds, and then we hit enter. So it goes through and everything works fine. So basically here, there were no problems, so it went through. So that is the basic ping command. So with the ping command, you can go out and you can ping, devices and things on the network. You can also ping devices and such on the internet. So we could do ping space www.everymanit.com and hit enter. And now we are getting a response from everymanit.com. Like I say, everymanit.com is sitting in a data center a few miles away from here. Well, the first thing that happens is the ping command resolves the IP address of everymanit to 207.114.53.132, and then it pings 207.114.53.132 4 times. Here, you see that the time it takes is 25 milliseconds. So the first one was 25 milliseconds, 22 milliseconds, 37 milliseconds, 25 milliseconds. Again, if we look up here, pinging our own default gateway took less than 1 millisecond. So this does show you that it takes a little bit of time. I mean, it's milliseconds, but it does take time to go out there and talk to the server sitting out on the internet. Now finally, so we'll clear this out, we are going to look at the trace route command or the trace ert. So you don't put in trace route, you put in TRACERT. So with that, it's TRACERT, and then you put in whatever IP address or domain name you want to trace to. So with this, again, let's put www.everymanit.com. So what this is going to do is it's going to trace the entire route it takes to get to the everymanit.com server. So we hit enter, and so we see again it resolves the domain name to 207.114.53.32, and now the first hop, the 10.1.10.1, is our default gateway, and then from there it hops to the closest Comcast server. From there it hops to the Baltimore Comcast server, to the DeSoto Comcast server, to the White Marsh server, to New York. So it goes all the way up to New York. Then it goes down to McLean, Virginia. Then it goes to Ashburn, Virginia. Then it goes to the 75.149.231.162. This is one of the routers that is sitting at the data center, and then it comes to the actual server. So this shows you the entire route that the command takes. This can be very important when you're dealing with large networks. Now, when you're dealing with small networks, the small office with 10 users, You rarely ever have to use a trace route command. But if you're going into a network, a very complicated network where you may have 20 or 30 routers, you have communications going, you have 100 remote offices, you have 2 major offices, there's all this communication going back and forth. Using this trace route command can be very helpful to try to figure out how communication is going through all those individual networks. So with that, let's go back out to the outside world and talk about network mapping software. So those were the simple DOS tools or DOS commands you can use just to start understanding what your network looks like. Now, the best tool, once you have a vague understanding of what your network looks like, is to use network mapping software. Now, network mapping software, this is full-fledged software. You can get it for Macs, you can get it for Linux, you can get it for Windows, etc. What this software does is it tries to go out and grab information about your network. Now, this network mapping software, some of it is free, some of it is open source, some of it costs you $5,000 a license. The cost really depends on how much information this network mapping software will get for you. The big thing to understand with network mapping software is this software, all the different versions of it, are built to do different things. So you may go out and you may go to downloads.com or softopedia.com and you may see 50 different pieces of network mapping software. And what you should realize is all these pieces of network mapping software do things differently. They look for different information. Some of it will give you back very simple text files. Others will give you back these really fancy pictures and will show you how all the devices connect to each other. Some, all they do is they go out and they look for open ports and open shares. Others, again, they map everything and they will tell you all the software that is installed on each and every computer. So the main thing to understand about network mapping software is, it's anywhere between free and open source to $5,000 a license. I'm not joking about that $5,000 a license. And it all does stuff differently. So depending on what you are trying to get will depend on what software you end up using. So we're going to do a little demonstration. The first demonstration I'm going to show you is with a really quick light piece of free software. What it does is it goes out, it scans for all the devices on the network, it looks for open ports, and it looks for open SMB shares. These are basically Windows file shares. That's all it does. There's nothing fancy, there's nothing cute about it. It's just a very quick way to go out and scan your entire network. The next piece of software that I'll use is something called Spiceworks. Again, it's free. Why? Because I'm teaching a class for you, and I'm not going to spend $5,000 on a piece of software. But the nice part with Spiceworks is it can actually go out, it can inventory software on computers, it can determine what types of devices certain networking equipment are, so it can say, oh, this is a router, oh, this is a switch, oh, this is a wireless access point. It will tell you the operating system that is sitting on whatever network device it finds. So even if it can't figure out what something is, it can tell you the operating system on it. So it'll say, so I'll show you, hey, this has a Cisco operating system on it. Hey, if it has a Cisco operating system, it's probably a piece of networking device. So with that, let's go over to a demonstration on network mapping software. It's very easy to use. The one thing that I will tell you is I will, at this point, only show you the results of the network mapping software because network mapping takes a while. So even on a really pathetically small network that I have here in this building, it takes 5 or 10 minutes to run. So if you're going to map a network of 100, 200, 300, 1,000 computers, basically just set the thing to go for a night and then come back. Don't expect that network mapping software will work in 5 minutes, because it won't. Okay, so we're back on the Windows 7 computer, and I'll show you two different types of network mapping software. The first is something called Port Scan, and then the second will be Spiceworks. These are both free pieces of software. The first, Port Scan, I will just bring up. Like I said, the live action part of the class, I'm not going to run a scan right now because running a scan, even on a small network like mine, does take time. This takes physical time. So if you're going into a large network, what I would tell you to do is plug in your laptop and immediately start the scan. Don't wait to do the scan until you have to leave in half an hour, because it will take a while. So with this very simple scanning software, this scanning software will go out. It will look for what devices are on the network. It'll look for the MAC address. It will look for open ports, and it will look for SMB shares. So like I said, again, all this software does different stuff. Some of it is really quick. Some of it's really pretty. Some of it's really in depth. It just depends on what you go out to buy. So we can see here, it scanned through the network. So it found host 10.1.10.10, gives the MAC address, gives the host name, so the computer name is graphic, and then it shows what ports are open on this computer: HTTP 80, IPMAP 135, HTTPS. All of these ports are open on the computer, and then it says what shares are open. So the user's share is open. So if you want to try to connect to this, you may be able to connect using the share for users. Under this, it shows 10.1.10.3 and the MAC address. It shows open ports, but it doesn't give you any more information. So again, this isn't a very in-depth scanner. It just kind of shows you what's out there. 10.1.10.11, the same. So it shows you it's there. You still don't really know what it is though. .16, .13, so you can see host name. Oh, this is a gateway laptop, so that's something. 10.2, 10.1, again this has open ports, so this gives you an idea of what devices and computers are on the network, what ports are open, the host name if it's available. So this port scanner will run very quickly, but it gives you just very, very, very basic information. If all you need is basic information, that may be, again, all you need. Then we open up this piece of software called SpiceWorks. So this is a much more complicated piece of network mapping software. Again, it's free, but it gives you more information of what's going on. So here, this will actually show you the types of devices that are on the network. So you can see right now there's 2 workstations on the network, 2 servers on the network, 3 networking devices, 1 other, etc. So I can go onto this workstation, click, and it shows I have that gateway laptop, and then I have the graphic computer. If I click on this graphic computer, like I said before, this is a more in-depth piece of network mapping software. I can go down, I can see it's a graphic computer, I can see the motherboard that is on it, I can see that it has an Intel Core i7 processor, I can see it has Windows 7 Professional, I can see it has 4 gigs of RAM. So this is all information that the other piece of software didn't have. You can click on the configuration. It even shows local C drive 29% free, local F drive 65% free, E drive, oops, look, E drive is full, so I need to take a look at this computer and see what's going on. So this gives you lots and lots and lots of information about the computers that are on your network. So if we go back to inventory, we can go over to networking. And here we can say, oh, look, this looks like a wireless access point. So this is an Apple wireless access point. And it tells you some information couldn't be found. We can click on this. So it says this is a Cisco device. We can go over here. This is an SMC. So this is the 10.1.10.1. This is our default gateway. So with, like I say, a more robust type of networking software, this can go out and it can scan all the devices, the computers, the servers, everything that's on the network, and get information about them. So like I say, with graphics, the graphic computer, not only can I see it's Windows 7 Pro, 4 gigs of RAM, but I can actually click on software, and this shows me all the software that's installed on this computer. So, if you're trying to go out and you're trying to do an inventory to make sure you don't have pirated software on your computers, this can be very, 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 very valuable. So this is SpiceWorks, and I also showed you port scan, again, depending on what you want. it depends on whether one of these pieces of software is good for you. So with that, let's go back out to the real world and talk about security considerations. So now that you've seen how easy it is to map out a network, you might be thinking, I have a lot of security holes here. So the first thing you may want to do is run out and try to close all of those security holes. The first thing that I am going to remind you is, the more things, the more services you shut down, the more complicated it is going to be to administer a network. So you can close down all these services. You can turn off SNMP, Simple Network Management Protocol. You can turn off ping request, etc. But if you do that, it is going to be very, very, very very difficult to map that network if another technician comes in behind you, or if something just weird happens. So the first thing is, if you want to shut down the ping service. So ping is the basic service that almost all of these network mapping pieces of software use to determine if computers exist. So you can shut down that ICMP echo request. Now, if you're dealing with a router, so let's say you have a router that is sitting on the internet and you don't want anybody to be able to ping that router. Within almost every single modern router, if you go into the settings page, there will be a little thing that allows you to turn off the ping request. So if somebody tries to ping your router, it simply will not send a response back. So basically, the computer out on the internet tries to ping that router, and then the router ignores it. Now, if you have normal computers sitting on your network, normally in order to stop this ICMP echo request, you have to install security software. For whatever reason, you cannot just go into Windows and say, don't respond to ping requests. You actually have to turn on security software. So, you just pick up McAfee or Avast or whatever else is out there, and that software will turn off that ICMP request for you. Then, if you want to turn off the pings, that's how you do that. The next thing, the big thing, is then SNMP, the Simple Network Management Protocol. Now, with this, on all Windows computers, you can go in and you can actually turn the service off. So if you turn that service off, then SNMP will not work on that computer at all. Whatever agents or whatever else is installed, it just stops working. Or you can use the firewall. Again, it uses UDP, ports 161 and ports 162. So if you turn on the firewall for that local computer and prohibit outbound traffic on ports 161 and 162, that will stop SNMP from working also. Those are the ways that you can secure your network. But again, think about it a lot, because SNMP is a very, very, very useful tool. If this is the first you have heard about it, before you go rushing to turn it off, think about how useful it is to use. I mean, think about being able to look at any computer on the network and see what is installed on that computer, see what the hardware on that computer is, be able to get those alerts. I mean, that can be very, very useful. If you're not using it, if you have no interest in using it, by all means, shut it off. Again, with that whole ping and the ICMP echo command, be very careful with that, because yes, if you turn it off, it makes your network quote unquote more secure. It also makes it a much bigger pain in the butt to actually try to administer if something goes wrong. So I would never turn off ping. Not me. I mean, maybe I would turn it off for the router to the outside world, but internally inside my network, there's no way in hell I would turn ping off. But those are the things that you should think about for the security of your network. So that was a short class on network mapping. Network mapping is an invaluable tool for IT professionals. Like I say, especially when you're going into a brand new network or a network you haven't seen for a while, being able to plug in your little laptop and have it run a scan of the entire network is just a great thing. Whether it gives you just an overall idea of what's on the network, kind of refreshes your brain on what's going on, whether you run it to see what security problems there are. So I talk about things and people laugh at me for it, but it's true. There are so many obsolete computers that people have not touched in the past 5 years that are still running on networks, especially once you start dealing with large networks, networks of 100 or 1,000 users. I can guarantee you there are computers just putzing along day after day that nobody's doing anything with. Well, the problem is those computers are then vulnerable to hackers, attacks, viruses, etc. Because if nobody remembers them, then people probably aren't updating them. Virus updates aren't happening, etc. So these computers may be just sitting on the network, chugging along, and they're just little hives of virus and hacker activity. By running a scan of the network, you can figure out those old obsolete systems and rip them off the network. Also, like I say, with the SNMP agents and traps, you can make sure that all of your computers are up to whatever hardware or software standards that you require. So you distribute all these little agents out there in the traps, and you can see what computers have less than 2 gigs of RAM, what computers have a slow processor, etc. So if you go to your client or if you go to your boss, you can give them a report and you can say, hey, listen, out of 100 computers, we have 10 computers here that obviously need upgrades of RAM. It just makes your life a lot easier. So again, this was the class on network mapping. This is an invaluable thing. Whatever network mapping software you decide to use, again, is entirely up to you. Remember, the free open source stuff isn't as good as the expensive $5,000 stuff. So depending on the size of your network, don't always go for the free stuff. If you have 100 users or 100 systems, if you have 1,000 systems, buy the expensive software. It really will do better for you. All the software does different stuff. With SNMP software, management software, the more expensive stuff you buy, it's really, I swear to God, it's really worth the money. So this was a class on network mapping. Again, I'm Eli the Computer Guy over here for Everyman IT, and I look forward to seeing you at the next class.